A standard question on combination is that of forming committees. Let's say we want to form a committee of 7 members from 8 women and 9 men who are available. There's no other condition given, so let's take different questions out over here. The first question, there's no condition. If there's no condition, the fact that there are men and women is very incidental out over here. All we can look at is 9 and 8. There are 17 individuals that I have, and I want a committee of 7. Since it's a committee, it's a selection, and the answer is going to be here 17C7. Question number 2, let's say the committee such that 6 are women. So it is specified that 6 are women. So there need to be 6 women, but the committee is that of 7. So that means there should be 1 man in the committee. The 6 women have to be selected out of the 8 women, and they could be selected in 8C6 ways. The 1 man has to be selected from amongst the 9 men, that is 9C1, which is same as 9. For each selection of women, so consider any one selection of women in your mind, the man that could come in is 9 different ways. For each of them there are 9 further ways, so you multiply it. The third question, let's say such that at least 6 are women. The difference between the second and the third question is this word here, at least. And there are quite a few questions, and this word at least should immediately catch your attention. And there's a very standard procedure to think, the moment you have an at least, make out cases. That is, break it into cases. Break into cases using an or. Using or. So start with 6, at least 6. So that means there could be 6 women, or there could be 7 women. There couldn't be more than them because a committee is that of only 7 members. If there are 6 women, there also needs to be 1 man out over here. Here there would be no men. So in how many ways can I select 6 women and 1 man? That I've done as the question number 2. So that is going to be straight out of 7, select any 6, and out of, sorry, not out of 7, out of 8. 8 women, select any 6, out of 9 men, select any 1. Or means an addition, out of 8, select any 7. 9C0 is 0 itself, so we'll leave it out over here. And one more question here. Let's say such that at least 1 is a woman. Let me rewrite it. At least 1. Now the word at least is still here. And how many should be women? There should be at least 1 woman. So if I consider the same as the previous one and break it, I would have cases where there could be 1 woman, or there could be 2 women, or there could be 3 women, and so on. If I continue this thought process till last case, or there are full 7 women. Now these are plenty of terms. There are 7 such terms. So I would be getting 7 such let's say terms out of it, which is a pretty lengthy one. And that is where you should realize this is at least 1, and this at least 1 makes a job very easy. How does it make us a job easy? What is the only case, the complement of this, that is not acceptable? If I also include a 0 women case, if I include, could I say now that this entire range takes care of all possibilities? 0 women, 1 woman, 2 women, 3 women, all 7 women. So this is nothing but your first case that you are forming every possible committee. So this is nothing going to be but 17C7. However, what we do not want a 0 women committee. So from this, just subtract all a 0 women committee. And 0 women means all of them are men, all the 7. From how many are we selecting? From 9. So that will be 9C7. And this would be my answer to this question. So remember, let me erase this and write it in bold actually. So this takes care of all these questions. What I want is just to highlight the fact that at least one should always capture your attention. And you should always be able to write at least 1 as nothing but total minus none. I'll take up a question on this funda once again, though it is not related to combination, but since I'm at this point, let me use this. Let's say, going back to numbers, using 1, 2, 3, 4 form 4-digit number such that at least 1 digit is repeated. Quite a few of us would start with that the first position could be repeated in 4 ways. And having filled that in, I could reuse the number. So you would say that I could again use 4 ways, but this does not necessitate that you would have used the number. Could they even be different? Yes. So we would not be able to proceed this way, and your immediate attention should be at least 1. So the moment at least 1 is repeated, think about it, total minus none. What sense does total mean? Total means form every possible numbers. Repetition, no repetitions, form every possible number. So let's say repetition. So this total is nothing but 4 into 4 into 4 into 4. So I formed all possible numbers out over here. So if I look at these 256 numbers, would that include a number like 1432? Yes. Would that include a number of 1443? Pretty much. Would that also include every possible ways? 3214? Yes. Could that also include a number 4444? Pretty much, right? From this minus none, we want a repetition. What do we mean by none? None means no repetition. And no repetition is nothing but 4 into 3 into 2 into 1. So what we are doing when we subtract is, we are taking cases and we remove off when there is no digit which is repeated. So what is left would either have 1 digit repeated or more than 1 digit repeated in that case, right? So this is an aside out over here just to highlight the fact that at least 1, wherever the word comes in at least 1, you could use total minus none. Let's get back to our committee questions. There is one more question here that I would like to do. Not to solve a question, but to highlight that there is an error, and a very, let's say, error very hard to detect which gets formed. So, same question, committee of 7 from 8 men and 9 women. Let's say such that at least 4 are women. So what is the big deal here? There's an at least. So let me break it up. So I could have 4 women, or I could have 5 women, or 6, or 7. Okay, so this is reasonably lengthy. Could I work by deleting or subtracting the numbers which I do not want? Let's try it. So the ones that I do not want are 3 women committees, 2 women committees, 1 women committees, 0 women committees. Oh, so this also is equally long. So whether you go the forward way or whether you go the reverse way, it is going to be equally long. So I'll just write the sort of answer to this. 4 women is 7C4. The job doesn't end there. I also need to fill in the other 3 positions from men. I'm sorry, again, there are 8 women, so that's 8C4, 9C3, or 8C5 into 9C2 men, 8C6. This is what we had done earlier also, 9C1 or 8C7. This is the correct answer. And I repeat, there is no other way other than writing this whole expression. Would I need to calculate this? Not really. Mostly the options will be in this format itself, so you don't have to calculate as such. But you cannot avoid writing this or so on. A classic way that some intelligent or a very curious student could do is, at least 4 are women. So out of 7, let me select 4 women. This ensures out of 8, select any 4 women. This ensures that 4 are women. Having done this, the 4 women have gone. Am I left with 4 women now? Now out of this group of remaining, I have to select 3 people. And is there any condition, or could I take all 3 women again? Pretty much that will be a committee of 7. Could I take all 3 men as well? Yes, that would be committee of 4. So what quite a few of us think or so on is, having done this, I am left with 9 and 4, that is 13, and select any 3 out over here. So this looks like a pretty tempting alternative to the previous long expression. However, this is wrong. You will never be able to satisfy an at least condition and free to select anyone else. This select anyone. This thought process will never be useful. What is wrong out over here is a little difficult one to let's say to identify. So let us go ahead and see what we are doing. When we say 8C4, we are writing every possible way of selecting 4 women. Let me just identify them. So one of the way is women 1, 2, 3 and 4. Would there also be another possibility that there is a women 1, women 2, women 3, women 5 selected? Yes. Why? Because this lists every possible way. Having done this, for each of them there are 13, we say there are 4. 13C3. In this 13C3, we have selected any other of the remaining people, select any 3. Well, one standard way is man 1, man 2, man 3. Which is okay. But is there a possibility here that I might have selected man 1, man 2 and women 5? Yes, because out of all the remaining I can select any one, and so on. There could be further many possibilities. For another case of the previous way, let's say the second case, again there are 13 people left, but the left people are different now. Women 4 is left, 5 has come in. Could I select any 3 out over there? Okay, possibly I might end up, or there is definitely one way of selecting which says man 1, man 2 and women 4. If you look at it, this committee is eventually made up of what? Women 1, 2, 3, 4 and 5, man 1 and 2. Okay, so even if I want to write it, women 1, 2, 3, 4 and 5, man 1, man 2. This committee here also, if you look at it, is made up of the same people. So I would be counting this committee twice. In fact, over it, this same committee, I would be counting it many times over. How? It is quite possible that I might have selected women 2, women 3, women 4, women 5 in the first instance, and amongst the remaining one, I could have selected man 1, man 2 and woman 1. Would this also result into the same committee out over there? Pretty much, right? So there are many double counting in this process. One might think, why don't I just correct myself by checking how many times will I count it twice? You would not be able to do, because let's say the first committee, this is being counted only once. The moment you have man 1, man 2, man 3, you cannot have any one of them in the mandatory pack. So you will not, there are quite a few committees here which will count many times over. Some of them you will not be counting, you will be counting only once, and there are some, the number of times you count is not constant. A completely women committee could be counted in many different ways, right? So this process, entire process does not yield us an answer, and the only other way is that longish expression that we had written earlier. One more question on combination. It's an easy one, also an interesting. So let's say I have 16 players. Out of those 16 players, let me just name them. One is Sachin, one is Rahul, and there are 14 others. So 16, think of it as a group of 16 players, and I want to select a team of 11. So I want a team of 11 in this case. In how many ways can I select them? If there is no condition given, it's pretty obvious it's going to be out of the 16, select any 11. Right? However, if I say a condition such that both Sachin and Rahul are selected. If Sachin and Rahul are selected, Sachin has to be in the team. I don't have a choice with that. If Rahul also has to be selected, Rahul has to be in the team. So now what is left? I need 9 other people in the team and they have to be selected out of 14. So the answer is going to be in this case 14C9. And that's my answer and over. How about if I say neither Sachin nor Rahul has to be selected? So Sachin, Rahul, neither Sachin nor Rahul is selected. Again a pretty easy one here. Since Sachin is not to be selected, let's consider he is not there. Even Rahul is not there out over there. So what do we have? We have 14 and out of 14 I need all the I still need 11 players. So the answer is going to be 14C11 in this case. So pretty easy ones here depending upon the condition. However, the condition can add a little difficulty. How can that be? Look at this question. So Sachin, Rahul, 14 others. The condition now is if Sachin is selected, Rahul is not, and vice versa. That is, if Rahul is selected, Sachin is not. Now, in how many ways can I select a team of 11? We still need a team of 11. Let's take cases out of whether. Sachin is selected, Rahul is not selected. How will this team look like? Sachin enters the team. Rahul is not present with us. So there are 14 players left and I need 10 more players. So in how many ways could I do that? I could do that in 14C10 ways. Similarly, the vice versa case, Sachin is not selected, Rahul is selected. So Rahul comes into the team and Sachin cannot be selected now. Out of 14 I need, so it's going to be same as 14C10. And it could either be the first case or the second case. So let me just clear the board a little and continue with this question. Yes. Quite a few of us stop at this moment and say the answer has to be the addition of them because either this is going to happen or the other case will happen. Neither. Is this the final answer? That is where the difficulty is not in the C business, which we all can do it very well. The difficulty is in interpreting this says it is a question of if Sachin is selected. So if both of them come running to me and I were the selector and they say, Ki, look, if you select him, I will not be playing. If you select me, he should not be there. Then the simplest thing is don't select any of them. Ask both of them to go back. So could I also do the possibility that neither of them is selected? Pretty much. Let me again explain it to you. The one that we have found ensures that exactly one of Sachin and Rahul is selected. Exactly one of Sachin or Rahul is selected. So the wordings could also have been this. If this were the wording, this is my answer. But the wording is if. So I could even not select both of them, and not selecting both of them, we have already done them. Don't consider they are present. So the answer is going to be 14C11. And if you actually look at it, and if you are well versed with possibilities, there is a yes no possibility with 2 people. So the total number of possible cases are just 4 of them. Either both are selected, Sachin selected, Rahul not, Rahul selected, Sachin not, or not. So all these 3 are acceptable to us. So this is not acceptable. So could I also do the other way and say total possible ways of forming a committee is nothing but 16C11. forming the team. From this, take out the case of both of them being selected. And how many ways can both be selected? Both are into the team. So 14, I have to select 9 out of the 14. So this expression is also my answer, and so is this expression my answer. Both of them numerically will turn out to be equal. So these are a few questions on forming a different types of committee or forming a different types of team. Combination is very challenging because it comes across in situations where there's no committee, no team and nothing, and you have to identify that you would be using a combination. That is what the next video is all about.